Okay, let's dig into MCP. This is the part that is shifted the most quickly. Recently, customers have started describing the architecture their teams are moving toward in MCP vocabulary, without being pitched anything. So to quickly frame the discussion, MCP, or Model Context Protocol, it's an open standard that lets an AI tool discover and use specialized tools and services. The mental model is moved from AI tools that you install to specialists that your AI can call. And that difference may sound mundane, but it's a fundamental shift in how this market thinks. The architecture has stopped being something that vendors propose. It's now something that customers are pulling toward, often before any vendor brings it up.
And the easiest way for me to make this concrete is to actually show you. So we have had a QVscribe MCP connector in active development for the past couple months now. Before I do share, this is early, so what you see won't look identical to what's in production even 6 months from now. We're sharing it because at this stage, the architecture is what matters most to this conversation, not the polish. And the best feedback we get comes from showing it early to engineers like you joining us today. So I'm going to go ahead and share my screen. So this is Claude Desktop, Anthropic's AI assistant. Notice we haven't opened a QVscribe surface. There's no QVscribe app. I'm in the tool that I'm already using. And that's really the point. The QVscribe MCP connector is already installed here in the background. So Claude can call to QVscribe whenever the conversation needs it. I just need to ask. So I've got a set of requirements in an Excel document here uploaded. So I'm just going to say, analyze these requirements using QVscribe. All right, so while this runs, the thing to kind of watch out for is what comes back isn't a generic AI output. It's QVscribe doing the analysis under the hood. It's the same engine, same rules, same standards I'd apply in QVscribe itself. Claude isn't going to grade the requirements. QVscribe is. It's just that Claude is the surface. All right, just need to log in. And there we go. All right, so there it is. The card you're seeing here is exactly what Martin and I were talking about in April. The scribe, which is Claude, and the gavel, which is QVscribe. So they're doing different jobs. The fact that I can see them working together inside one surface is what MCP makes possible. Martin, anything you want to add quickly here?
Yeah, the structure of this panel. So the issue categories, the quality indicators, the category breakdown. None of that is invented by Claude on the fly. It comes from the MCP tool that's returning structured, deterministic data. And that structure is what makes the audit trail real.
Yeah, and everything here is also interactive, very similar to QVscribe if you're familiar playing around with it. I can click into any of these things and Claude generates a follow-up prompt to dig in and start fixing it. Something like using similar requirements. If you've seen QVscribe, that's something you're familiar with. But for now, I'm going to take a look at one individual requirement. So this requirement here, requirement 5, says the driver shall be able to use buttons on the steering wheel to set and change the maximum speed whenever the system is engaged. So this currently has a superfluous infinitive alert. It also has a quality warning for passive voice, and then 2 alerts for template non-compliance for the ears syntax. So we also have, very similar to QVscribe, all of these words are highlighted so you can easily see what the problem is. Very helpful. So I'm actually going to use suggest rewrite to get QVscribe and Claude to work together to suggest a rewrite for this one.
Yeah, and notice what Claude is not doing here. It's yeah, as you'll see, it's not just making the sentence cleaner. It's going to respond to the specific flags that QVscribe returned. So the rewrite is shaped by the evaluation.
All right, so here's the rewrite that it has. When the driver engages the abstract system, the driver shall use the steering wheel buttons to set and change the maximum speed. And here's the part that matters to me the most. I'm not just going to trust that this rewrite here is better because it looks better. I'm going to actually add Claude to run this compare requirements and tell me exactly how it's doing. So, and this card here, compare requirements, that is the MCP handshake. Claude's not pretending to do the comparison itself. It's asking QVscribe to, and I can see exactly what's being passed. And there we go, confirmed clean. We have all of these different alerts resolved. So we can be confident that this rewrite itself is better.
Yeah, that visibility that Morgan just described, that's the part that really matters in regulated work. For a certification audit, saying, that the AI did it, that's not an answer. But saying, the AI asked, the AI asked the evaluation tool, here's what it asked, here's what came back, that is an answer. And the implication of the life cycle is worth naming. What you just saw goes beyond a rewrite. It's the requirements layer becoming clean, structured, scored, traceable across versions. And clean requirements can be reasoned over by downstream AI tools for test generation, verification, design analysis, and so on. And those existing downstream tools may work just fine, but they still need clean input to do so. And that's the lifecycle argument that our April webinar, from that webinar in working form. Um, the evaluation layer is what makes everything downstream actually viable. And there is a broader frame to this. Governance is not confined to the requirements layer. Once requirements are clean and traceable, that same governance pattern has to extend across design, verification, test, certification. That's the next chapter of this work. And the architecture we're describing today is what makes it possible.
Exactly. And the practical version of this for this audience is that this isn't a new surface for your engineers to go to. It's not another login currently or another tool to learn. If your team's already using Claude or Copilot or Rovo or maybe an internal LLM, the intelligence layer becomes reachable from there. The way I've started putting it is that your team doesn't come to us, we show up where you are. And honestly, what I hear from engineers a lot of the time is that if a tool adds an extra step, they're just not going to use it. They'll tell you this is more work and then find a way to work around it. The MCP helps remove this step. One honest caveat, the connector you saw is working cleanly inside of Claude Desktop, but the approach across Copilot, Rovo, or your own internal LLM is still in progress. So the architecture is portable, but the rough edges are real. And we'd rather have this conversation with the people in this audience while the connector is still shapeable rather than wait until it's fully polished.
Yeah, and to pull back from the demo for just a second, the reason the MCP matters now is that the AI tooling market is shifting in a fundamental way. So horizontal AI tools, Claude, Copilot, Rovo, ChatGPT, they're absorbing the generic capabilities, summarizing, restructuring, drafting. And so the value moves to specialists that can be reached from inside those tools when the question gets serious enough to need them. And so what you just saw is what that architecture looks like when it's built for that future deliberately, not just another product fighting for screen time inside someone else's tech stack.
Yeah, and that's exactly what we're hearing on the customer side too. A year ago, I'd hear a question from teams already using QVscribe saying, do we need this if we already have Copilot? But now it's how does this work alongside Copilot? It's the same teams, but a different question. And the framing has really flipped from being competitive to complementary. And that's a real signal for where the market is now.
Yeah, there's one distinction worth listening for because over the next year, you're going to hear a lot of vendors say, we have MCP. Some are adding it as a feature, kind of a single connector bolted on to check a box. Others are treating it as the substrate, built to be reachable by any AI tool. And to tell the difference, Ask what happens when the service you want to call them from is not on their connector list. If the answer is, well, we'd have to build that, it's a feature. If the answer is any MCP-aware client can already reach us, well, that's substrate. And that difference compounds over time. The feature version locks you into whatever tool suite they integrated with, while the substrate version travels with your team as you adopt new surfaces. So what we just showed is substrate, the same QVscribe engine reachable from anything that speaks a protocol.
And Martin, I have to ask the air gap question. For those of you in the audience who can't use any external LLM path at all.
Right, right. So yeah, for defense and classified programs, the models that you can run internally are usually older and smaller than what's available outside, and that's structural. But because our evaluator is deterministic, it applies your standards the same way every time. Whatever model is on the other end. So, the older model, does the generation, and the deterministic evaluator is what makes the result defensible. So that architecture works. Whether the model is bleeding edge or, maybe two generations behind, same standards, same evaluation, same record.
Yeah, and I'll be honest, getting that into a true air-gapped environment is its own conversation, not a one-liner for today, but the principle does hold that the delivery is the hard part.